Oh yeah, here we go into a very cool video on how to figure out the pattern in a sequence and write it out as what is known as an explicit function. So what that means is we're basically going to look at the pattern and come up with the nth term or the function that will give us any number of terms. So if I wanted the 150th term, I could just plug in 150 to figure out what the 150th term is. Let's check it out. So find the next two terms and the nth term of each of the following. To do this, it's very difficult, I think, to just look at the pattern and say, yeah, negative 3/4 to 9/8. I know exactly what's happening there. I don't think that's that easy. So what I like to do is I first like to look at the signs and see if they're alternating. And they are. We're going negative, positive, negative, positive. So we know that this is the n equals first term, n equals second term, n equals third term, and the n equals fourth term, and so on and so forth. So it appears that our signs are going negative, positive, negative, positive. So when that happens, we've got, well, I'll start out with the nth term. A sub n is equal to negative 1 to the n. And we test it. If I plug in 1, I get negative 1. If I plug in 2, negative 1 squared, I get positive 1. If I plug in negative 1 to the third, I get negative, and so on and so forth. This term creates that alternation. So we kind of piece this thing together. Then I look at just the numerator. Right, let's just look at that. So just the numerator, it goes up by, well, let's see. It looks like we're multiplying by 3 each time. Right, and the trick that you could do with this too is you can see how much you're literally going up by. Plus 6. 9 to 27 would be 18. And again, we're ignoring here the negatives. And you're just saying, okay, I need to go 9 to 27 is up by 18, and this is up by 54. And what you might notice if you haven't noticed before is it's times 3 every time. Right? So we're multiplying by 3 each time, even in the differences. So that's going to be something exponential. I'm multiplying by 3, by 3, by 3 to get every term. That's exponential. So 3 to the first gives me 3, 3 to the second gives me 9, 3 to the third gives me 27, and so on and so forth. So 3 to whatever term number gives me that value. So now we've put together our numerator. Now let's look at the denominator. We go piece by piece. The denominator goes 4, 8, 12, 16. It looks like we're adding 4 every time. And when you've got that single level of adding by 4 every time, and then we look at the difference in those additions, almost like looking at the second derivative, we've gone up by nothing in between these, right? It'd be plus 0, which means it's linear. Your slope is constant. The fact that your initial difference, we call that the first difference, goes up by 4, the same amount every time, and the second difference is 0 every time. That means that we're linear. So I'm taking the nth term, and I'm multiplying that term number by 4. So that'd be 4 times n. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on and so forth. And that is it right there. So if I wanted, like, let's say the 60th term, all I would have to do is plug in 60 for n into each of those, and we get whatever the 60th term is. So for instance, a sub 60 would be equal to negative 1 to the 60th times 3 to the 60th, whatever that is. I'm not even going to calculate that out. It's massive. All over 4 times 60. And that would be the 60th term in the sequence. Definitely. And that's the cool part when we have these sequences. All right, so now let's take a look at this one. Again, we're going to split it up. Notice there's no alternation, so we don't have that negative 1 to the power term at all. And so I look at my numerators first. So my numerators go 3, 5, 9, 17, 33. And I don't quite notice the pattern. But look at the common differences between them, right? Not the common, I should say. Just look at the differences. We go up by 2. We go up by 4, we go up by 8, and then we go up by 16. And then look at the differences in those numbers if the pattern doesn't emerge yet. We go up by 2, we go up by 4, we go up by 8, and so on and so forth. So it looks like our differences aren't getting any slower, right? We're still going up and up and up. And if you notice, the difference is we go up by multiples of 2. Multiply 2 by 2, 4 by 2 to get 8, and so on and so forth. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So now, looking at this, we know that we've got a power again, that it's going to be 2 to the sum power, since we're multiplying by 2 again and again. So let's just kind of play around with this. Well, 2 to the n is not going to get me 3, right? This is the first term, this is the second term, this is the third term, this is the fourth term, and this is the fifth term. So 2 to the n will not get me to any of those numbers. But if I added 1 to 2 to the 1, I would get 3. So let's try that. 2 to the 2, right here, is 4 plus 1 is 5. Looking good. 2 to the 3 is 8 plus 1 is 9. 2 to the 4 is 16 plus 1 is 17. So this requires a little bit of tinkering, a little bit of guessing checking, but look at the differences and see if you can note the pattern in your differences, right? How much you're going up by. And when we realize we're repeatedly multiplying by 2, that's how we know it's exponential. It's a very neat way of doing some detective work. So that's the numerator. Now let's look at the denominator. So the denominators, I'll do this in a different color. The denominators are going up by 2 every time with no change in the amount that they go up by. And so that means that we're linear. We're going up by 2 and 2 and 2. So that would be 2 times n. And if you look at this, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. And then from there, we've got our nth term. So we've got a sub n is equal to 2 to the n plus 1 all over 2n. And this one right here, just like this one, if we wanted the, let's say the, I don't know, the 7th term, let's not go as big. All we would need to do is plug in 2 to the 7th plus 1 all over 2 times 7. And then when we simplify that thing down, we're going to get 128 plus 1 all over 14, which is 129 all over 14, which might not be something in the pattern that we would typically see, but if you wanted the 100th term or the 5th term or the 80th term, you plug in that n value, whatever number term you want, into your general term, the nth term, and you'll get out whatever term you want. That's a lot of terming. All right, that's it, guys. I'll see you in the next video. I can't wait for it, but for now, find those patterns, break them down into pieces, and even though this is a difficult idea, you'll get better at it. I got more in the exercises, so check that out too if you're having trouble with it. Peace.